Right, welcome back everyone, and I hope you're having an amazing summer for those who are enjoying the summer break. If you're still working, it's fine. I mean, we're all working, so it really doesn't matter. I mean, as long as you can find the time to, go out sometime and try to have fun. I mean, it's summer, even if you're working, just try to have some time for yourself to enjoy, and then because you most of the time this is the moment when people can get together with the family and try to have some fun and enjoy them, and then it's important for your mental health and also for you know to build the strength that you need to address the coming year. So I hope you're all having an amazing summer break. Oh, well, not summer break, but summer overall. So last time I posted one video talking about the new release of my software ResUMES++, which is a software used to process ERT data. And then if you don't know about, you can go to this website, which is thecase.com. It's my website or our website, my group, that I am leading. I'm happy to say. Yeah, it's really funny, but yeah, it's really enjoyable to see those things. Yeah, so we have this new release, and then uh, the information that you need to know about it is here, so you can have it, and then you can also download if you want to try it yourself. You can download from here. You just have to go to software and then click on downloading, and then you will have it. You can click on this icon to get to our social media and find informations, like more details, so to speak, about the software, and also uh, the new modules that we are developing within the software. And so today I want to talk not about this ResUMES++, but I actually want to talk about this module, which is within the software, but we are still developing it. So you don't have access to it yet, because this one is supposed to be something that you can use, and we believe you can use it without any um, problem, right? So in a way, this is like the very first stable release that we have, and we're still working on developing it, so expanding the range of functionalities that we were thinking about when we started working on this development. But today I want to talk about this module because it's really important. So for those who are familiar with the concept of ERT surveys or geoelectrical geophysics in general, you know that you can measure profile data, like those ERT data. Usually they are profiles, or you can measure vertical electrical sounding data, which is something you can use to have an idea of the different layers uh, present in your domain or in your region, the site that you are prospecting or studying. I don't know. Could be that you work in a mining project, or it could be that you just working for uh, I don't know. Maybe you're just doing some environmental studies, right? But you want those data maybe because you want to provide some sort of interpretation based on the conductivity of soil samples, for example. So this is just an example. It depends on what you're doing, but yeah, you can measure the ERT data with the profiles, or you can measure the VES data. VES, yeah, I think so. Vertical electrical sounding data. And it's also a profile, but not like the ERT. In this case, it's like a 1D data where you have the depth of investigation, and then you have the resistivity measured at the specific depth of investigation. So the reason why I want to talk about this here is because within this software, at some point, we are going to use the VES data to, in a way, guide our our understanding of the resistivity that we computed, right? Because from the VES data, we can have an idea of how many layers we have in our domain, and we can use that information to update our cross section of resistivity. So when I'm talking about updating the cross section of resistivity, if you watch the previous video that I posted, you will see now within ResUMES++ you can have sort of, not exactly, because there is no orientation included in that section yet, but you can have an idea of how many different layers you have in terms of geology or anything. But yeah, mainly geology, you can have an idea of what are the different formations below the surface if you can provide the information needed to get there. And one way to have that information is through the VES, because with the VES now I can have an idea of the different layers or the number of layers that I have, right? And so here I just want to show you what we have so far in terms of processing those VES data. Very simple process, very simple module. You just have to import, right, your data. So let's go right here, and should be here, and yeah, we should have something like this where we have the depth of investigation and then we have the resistivity, right? Next step, for now, we compute the covariagram from our data. This is important because we can use it to guide the inverse modeling. And again, here I'm using just statistical algorithms, right? I'm not using traditional, how do you call that one? I'm not using traditional inverse models like the Gauss-Newton algorithm, for example. I'm not using it. I'm using just statistical algorithms here. Okay. So we used an explanation model, and we need to fix this. Of course, we are still developing. I just wanted to show you, and then I also wanted to give you the information, the reason why we are working on this, so that if someone is interested and and that person wants to join us working on this, we are happy, and we will welcome you to our team, right? Yeah, anyway, we need the seal, which is like a limit. Usually the experimental model will guide you in terms of what could be a good number. Also, something important here, you can see this time I'm doing this manually, but for ResUMES++, I already have an automation to do this process, the variogram modeling process. Because I'm still developing, right? That's why it has to be manually done for now. So you need the nugget, and the next thing you have to do is to click here to go to the next page where you define the depth of investigation that you want to reach with your inverse model. This was inspired by ResIPy, because in ResIPy you can specify this depth of investigation that you want to reach, regardless the depth that you're reaching with your raw data. And I was like, yeah, we can do this. Could be fun. And you have to give a name to that block, right? You click here just to push it. Like, you want to tell this module that I'm ready. I want to compute the inverse model of the data, and I want you to go as deep as this number. So when you're ready, you press on start here, and if you're familiar with VES data, usually when you use a software like IP2X, this is what you have, something similar, right? Now, maybe I need to try another software to compare and see if what I have here is reasonable, but the idea here is you want to rely on the inverse model, right, to provide this green curve, which is the true model. And now this green curve is the optimal true model. Why I'm talking about optimal? Because most of the time those classical techniques, they really don't include uncertainty. I would say I've barely seen one that is including uncertainty in the result. And no, I think we see how important it is to really include that component. You cannot really provide a model without the uncertainty quantification. Is really important. In this case, we don't have a complete uncertainty quantification, but the idea behind having the true layers and the optimal layers is just because you have an output and then you want to play around with the realistic pattern of that output. How likely this is? Are you sure the number of layers that we have from the true model is realistic? And if we say it's realistic, what is the number that we use to, support that argument? So yeah, this is where we are with this module. And what we're trying to do here is we're trying to complete this and bring it back to ResUMES++. And now ResUMES++, we use it as a tool. Think about the way you use, for example, those creating toolbox in ArcGIS, right? You can call one toolbox and then use it and then take the result and use it somewhere else. So this is what we're trying to do here with this VES module. And so any comment that you have, any question, you can reach out to us. You can actually drop a comment below, or you can reach out through this website on this page, right? You don't have to put your name. That's why it's not required. It's not mandatory. You can just put your email, of course, because we will have to respond, right? We need something that we can use to get back to you with an answer if you have a question, or maybe with questions if you have feedbacks. And then usually all feedbacks are important. So yeah, if you have a feedback, maybe we want to expand, we want to explore your ideas. So we need something that we can use to get back to you. So yeah, you can use this page if you want, or you can just drop a comment below, and it will be nice to have some coming from different perspectives, like maybe from mining perspective or any other applications. We are really open to all those. So that being said,